there, I'm Ash and I'm from ScienceWorks, and we're gonna learn a little bit about secret messages in coding today. And I have a secret message right here. These candy hearts are spelling out a secret message. So let's look and see if we can figure out what it says. So I'm noticing there's a pattern to these candy hearts. I'm noticing each row has some yellow and green hearts, and they're not all in the same pattern from one row to the next. And I also have a binary code chart here. We're going to talk more about binary in a minute. We're going to see if we can decode this message. So code is any kind of arrangement of symbols that represent letters or numbers. And so we could make a code with a lot of different things. And binary refers to when there's two options. So if you think of a light switch is an example of binary, because if we flip the switch up, the light is on. If we flip the switch down, the light is off. So when we're talking about binary code for computing, we're talking about the number 1 and the number 0. So I'm predicting that one of these candy heart colors is representing a 1 and one is representing a 0. And I think we can look on our binary code chart and we can see what those letters are represented in the 1s and 0s of binary. So I'm looking at my chart and I'm noticing that every letter in binary starts with a 0. So I think that the yellow hearts represent 0s. And that means the green hearts must represent 1s. So I'm going to look here, and our second number in our binary code for every letter is a 1. We've got a 0, we've got a 1. So now I'm looking for something with just 2 zeros after it. There's quite a few numbers that could just have 2 zeros. And then a 1. So I'm looking for a number that's 0, 1, 0, 0, 1, 0, 0, 0. There's only one letter that has that, and that's an H. So this first letter is H. We can go through and we can decode every single line of this binary chart using this method. So I'm looking for a 0, 1, 0, 0, 0, 1, 0, 1. So I'm going to look at my chart. I found it, and it's an E. So our message so far, it says H-E. Now I'm looking for 0, 1, 0, 0, 1, 1, 0, 0. It's L. And now I'm looking for 0, 1, 0, 1, 0, 0, 0, 0. And that's P. So someone has left me a secret message in binary that spells help. So I want to find out who needs help. But they probably don't need help in a big emergency because they took the time to write me a binary message. So I'll find out who my friend at work is who wants to send me a secret message. So as we were talking about binary numbers and coding, we're also going to talk about how weaving relates to coding. And weaving is when you take threads and you weave them over and under other threads in a loom, and you can create a pattern like this. So weaving is a really, really ancient textile art. It goes back to the Stone Age, and people have used it to create cloth. Maybe if you ever look really, really closely at your shirt or at a carpet, you might be able to see that there are threads going over and under, and they can make patterns. So just like we were talking about how anything with those two states a binary is represented by two states. When weaving, that over and under represents binary 2. And so around the 19th century, there was a lady called Ada Lovelace, and during the Industrial Revolution, there was a lot of improvements in weaving machines. So people could make these woven patterns a lot quicker because they were actually programmed. The machines were programmed to do that. So Ada Lovelace saw one of these automated looms, and she imagined that maybe someday there could be a machine that could be programmed with punched cards of paper in binary to make patterns or music or write letters or even make art. So she was kind of imagining that someday we could code a computer type machine with binary code and do all the things that our computers can do. And she wrote a program for this machine. She's called the grandmother of computer programming. So I want to show you guys how we can make a pattern using binary, and we can use that to make a woven project with paper. So what we're gonna do, I have a little coding pattern, and I'm gonna have to make my paper that we're gonna make our code on first. So I'm just gonna take an ordinary sheet of paper, and I'm gonna fold it in half. I'm gonna fold that half in half. And then I'm gonna fold that half in half. So when I unfold it, it's gonna look like that. And then I'm going to fold it over like this. Now that I've got my paper folded, I'm going to cut some slits in it. So I'm just gonna go cut along the lines that I folded. And I want to leave a little space open at the top that's not cut. Basically, I'm making a loom out of paper. The loom is what we're going to do our weaving on. You can make a loom out of sticks, or you might have seen a loom made out of wood if you know somebody who does weaving. But we're going to weave on paper today. So when you finish, it's going to look like this. So what I want to do first is I'm going to think of how I'm going to make my code. And I think I'm just going to make an X for my woven pattern. So I'm just kind of drawing a pattern here for myself. And we could, make this look like whatever we want. I just want to draw something that I can do kind of quickly. But you can make anything you can fill in with these boxes, kind of like pixels, we can make into a pattern that we can weave. And so all the places where I filled the pattern in dark, that's where my paper strip is going to go over the thread. And all the places that are left empty, that's where the paper strip will go under the strip of the weave. We can also write this out as a code. If we're going to say O equals over, we'll say O. Then we've got 6. So we'll say U6 and then O. We could also write it out O, U, 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 O, but this is quicker. So for the second row, we would say U, O, U4, O, U. So you can write out your pattern in these little open spaces. And I'm just going to show you the first 2 rows. All right, so now I've got some strips of paper, and we're going to weave the code that I drew onto our little paper loom. So for our first row, our code is over 1, under 6, over 1. So we'll go like this. My little strip just jumped out the other side. So that's row number 1. For row number 2, we go over 1, under 1, or under 1, over 1, under 4, over 1, under 1. For row 3, we're going to go under 2, over 1, under 2, over 1, under 2, and then we're going to repeat that for row 4. Or no, we're not. For row 3, we're just going to go over 2, under 1, over 2, under 1, under 3, under 2. Okay, so far you can see each row is different. For row 4 and row 5, our pattern is going to repeat for the same row. So go under 3, over 2, under 3. Then we'll repeat that same pattern. Under 3, over 2, under 3. So for row 6, remember row 4 and 5 repeated. Row 6, we're going to do under 2, over 1, under 2, over 1, under 2. Now we had that pattern before too. Think about which row had that pattern before. Under 2, over 1, under 2, over 1, under 2. That's right, it's the same, it's the repetition of row 3. Row 7 is also going to be a repeated pattern. Row 7 is going to repeat row 2. That was over 1, under 4, over 1, under 1. And then we're going to repeat one more of our rows we've done before. Our last row, row 8, is going to repeat the same pattern we had on row 1. And that was over 1, under 6, over 1. So we can weave whatever we want to into our pattern as long as we can make it on the grid. And one thing you can do after you become an expert at this is you can just write out your pattern and not show your friend the grid, and you can just trade patterns with your friends and see if you can weave each other's codes. So hope you'll try this coding activity and have fun with it.